Question number 22. A loudspeaker emits sound of frequency fs. The loudspeaker is attached to a car that moves with the increasing speed directly towards a stationary observer. So you have a car and there's a loudspeaker here which is giving out the sound over here, and then there's an observer over here. It is moving towards it. Okay. What describes the frequency of the sound heard by the observer? What is a car that moves with increasing speed? With increasing speed, which means what? So initially, when the car is at this position, the frequency the loudspeaker emits is fs. Okay, but as it starts moving, what will be the new frequency? Frequency here would be f dash is equal to c minus v0 divided by c minus vs into f0 or fs over here. So which means what will happen now here? This v0 is 0 because the observer is at rest. So you will get this as c divided by c minus vs into fs. Now as the loudspeaker moves towards him, the apparent frequency will increase. So frequency will be greater than fs. That's right. So therefore frequency greater than fs is also right. So these two are incorrect. Now amongst these two you need to look into it. Now as it is moving over here, now what happens to vs over here? The source velocity. See, as it says here directly that increasing speed. Increasing speed means what? This value of vs is increasing, which means the observer will now be able to get more number of waves, which means the frequency is continuously increasing. Okay, first thing is that the value of it is larger than fs, and secondly the frequency is also seen to be increasing. It is like, for example, you are standing on a railway platform, okay, and a train is moving towards you and it's increasing in speed. What do you think? Okay, then the pitch of the sound that you hear would be much higher. So answer would be A over here. Okay, these two are incorrect. This is also the incorrect over here.